Well, hi guys, welcome. This would be, I guess, our official math lesson. First, but not the last, obviously. There'll be a lot. Um, for this little 4-day week, as we start getting into pre-calculus, I'm picking just a couple of topics to review that you should have learned in Algebra 2. Even in good years, sometimes people forget these or don't totally learn them, and last year wasn't a good year. There's lots of obvious disruptions at the end of the year, so this could possibly be new for some of you, or maybe you did learn it, but the year was so messed up you didn't really have a chance to sink in. I don't know. So anyway, today we're reviewing factoring. That's the overall topic. Now, factoring, there's at least 6 categories, and you could probably come up with reasons to name others that you can see on the screen. I'm not going to read it to you. I'm just going to tell you that today we are going to focus on trinomial factoring, difference of squares, difference of cubes, and sum of cubes. Common factoring, the first one does come up, but we're just not going to spend time on it. It's the easiest type. Grouping, we're actually going to kind of touch on that a little bit when we do trinomial factoring anyway, so I did not include that. Now, these 3 here all use formulas. I will scroll back up to this screen to write the formulas down when we get to that point. But we're going to start with trinomial factoring, which should be fairly straight up review from Algebra 2. Oh, you know what? I just realized there in fact will be some common factoring. I just saw that in an example. So my bad. We'll talk about that too. All right, anyway. What I'm going to do is normally I'll start a lesson with any sort of notes like in an open page like this, and then I'll transition into the examples that I'm going to use. I am going to do the even problems here as my examples, and then the odd problems will be your homework assignment. And then I'll provide you with a PDF if you want it, and you can obviously look at the video over and over if you need to. Okay, so number 2 is trinomial factoring. Tri means 3. There are 3 terms here. Starts with a square or second power. So that's a cue that this is a trinomial. Generally, what we're going to do here is the FOIL method, which you should remember in reverse. So these 2 numbers have to multiply together to give you b squared, numbers, variables, whatever. These 2 have to multiply together to give you 42. And then when you add these 2 up, it needs to give you negative 13. So that's what we're going for here. I'll get rid of all this mess. I just shoot for open arrows, and it usually starts with your variable, in this case b and b. b times b is b squared, and that's pretty obvious. Now for here and here, we need 2 numbers that multiply together to give you 42, but add up to give you negative 13. And you can write some things down if it helps, or you can just sort of brainstorm it. I'll go ahead and write down this time. I may not do it every time, but start with 42. 42 obviously breaks down into 1 times 42. It could also be 2 times 21, or 3 times 14, I think. 4 won't go in, 5 won't go in, 6 will go in, 6 times 7. After that, I get to 7 times 6, which is repeating myself in reverse. So there it is. There's all the combinations. Now, we need these to multiply to equal positive 42. That means they either both have to be positive or they both have to be negative. A negative 1 times a negative 42 is also 42. So consider that these could all be positive or negative. But the trick is they have to add up to negative 13. And for that to happen, the only possibility is if you look at the 6-7 combination. If they both happen to be negative, negative 6, negative 7, they do indeed multiply to positive 42, but they add up to negative 13. If you really want to check yourself thoroughly, this is what I think the answer is. You can go ahead and FOIL it together. b times b is b squared. Negative 6 times b is negative 6b. And I do know my 6's and b's look a lot alike. I'm sorry. B times negative 7 is negative 7b. Negative 6 times negative 7 is positive 42. Combine like terms right here. You get b squared minus 13b plus 42. And you see this is the original problem, which means all that work I did to check myself just proves that we're right. This is the answer. Now, on your work, again, I'm going to be asking you to do the odd problems, but at any time you can scroll down and check yourself. I just did number 2, and the answer is right there. So that is a good thing. All right, let's look at number 4. Now, number 4, also a trinomial. There's 3 terms. The first power is a second power. It's squared, however you want to say it. But this has what we call a lead coefficient. So it's going to make this a little more complicated. So these two still have to multiply together to give you 2n squared. And that's got to be 2n and n. There's not much other way to go about it. But now these two are not going to multiply together. Or I'm sorry, they will multiply together to give you negative 70, but they will not add up to negative 13 because of the way this 2 comes into play if you were foiling it out. So there's a couple methods here. There's just guess and check, which you can do. And there's this other method that I've never really been one to do, but I'm going to try it here real quick and see how it works. So I'm going to erase all of this. Okay, and so here's what we do. Multiply these together. You get negative 140. Now we come up with every possible combination of numbers that gives you negative 140. So that's negative 1 times 140. Or I guess it could be positive 1 times negative 140. Let's not worry about the sign right now, because then I'd be doing a ton of writing. But 2 times 70. 3 won't go in. 4. 4 will go in. 4 goes into 125 times, and it goes into 48 times. And 25 and 8 is... Wait, that can't be right. Okay, I'm having a brain attack. Sorry. 3, 12, 20. Yeah, 35. 4 times 35. Oh, I should have known that. Duh, that was simple. It ends in 0, so I know that 5 goes in. That's going to be 28. I don't think 6... No, 6 definitely won't go. 7, no. No, 7 will go. 7 times 20. Stupid. Okay, I'm stupid. 8 might go in. No, 8 won't go in. 9, 10. I don't know what else there is. Oh, well, yeah, 10 and 14. That's one I shouldn't skip over. 11, 12 won't go in, and then after that we get to 14. So there, that should be my whole list. So now, in order for this to be negative 140, one of these numbers has to be positive, the other has to be negative, but they have to add up to positive 13. So, can you find a pair of numbers that if you made one of them negative, the other one positive, they would add up to positive 13? Well, let's take like this one, for example. If I make this negative and this positive, they add up to 31, not 13. If I switch it around, make this one positive, make this one positive, this one negative, then that's negative 31. So clearly that's the wrong combination. But what combination works? Are you screaming at the screen right now like it's obvious to you? Hopefully it is. It's right here. If we had a negative 7 and a positive 20, that will add up to positive 13. So here's what you do. Write down 2n squared, and then your negative 7 and positive 20, you write negative 7n plus 20n minus 70. Now, look at the first two terms. Do they have anything in common that you can factor out? It looks like both terms have an n. So you factor out an n. So there's your common factoring. That leaves you with 2n minus 7. Now look at the next two terms. I'll highlight those. Do they have anything in common you can factor out? Well, 20 and 70, you can divide both of those by positive 10, and that leaves you 2n minus 7, right? If you distribute that in, you would have that. Now, do you notice 2n minus 7 and 2n minus 7 right there? They match. They're the same thing. That means 2n minus 7 is going to be one of the factors. The other factor is going to have to be n plus 10. And that is the answer. And this is what they refer to as, where am I? Right there, grouping. So we really have gone over grouping as well, and we've done some common factoring in there. So it's a lot of work. The more times you do it, the easier it gets. And then, like I said before, there are other methods that can also work. All right, and factoring is just, a real common algebra skill, and you do use very common algebra skills a lot in calculus and pre-calculus. Okay, number 6. First of all, it is a trinomial, but it starts with b cubed. And if you look, all terms have at least one b in them. So we are going to start with common factoring by factoring out the common b from all of those terms. If we take a b out of every term, that's going to leave us with 7b squared plus 10b plus 3. So this b, one of these two, one of those three, it's accounted for when you factor it out. So the b that's factored out right here, we're kind of done with that for just the time being. You're allowed to just ignore it, forget it even exists. Now what we have left is a trinomial, 3 terms, starting with a second power. So we need to factor that. I'm going to do the same thing I did before, where we multiply these two numbers together. 3 times 7 is 21, and come up with every combination to get positive 21. In this case, it's positive. So 1 times 21, 3 times 7, 7 times 3, that's about it. Now, which of these combinations are going to add up to equal positive 10? Well, clearly positive 3 and positive 7, right? So I'm just going to forget about that b for a minute. I'm just going to write down 7b squared plus 3b, well, maybe if I made it look like an actual 3. 3b plus 7b plus 3. Okay, let's look at the first two terms, the group. That's why this is called grouping. What do they have in common? Well, they have a b in common, so you can factor out the b. Just like we did with the first b, now we're doing it in this smaller group. That gives us 7b plus 3. Now look at the second group, 7b plus 3. What do they have in common? And the answer is they have nothing in common. Well, every pair of numbers has at least something in common. They have a 1. So you can factor out a 1. If you divide both of those by 1, you are left with 7b plus 3. And so we factor out the 1. It's kind of trivial, but it does work. It does make this work. We have 7b plus 3, 7b plus 3. That means that's going to be part of our answer. And then the other part of the answer is b plus 1. So that goes in this set of parentheses. And then finally, the first b that I told you to ignore for a while, bring that down and stick it in front. And that is the answer there. That is the factored form of this polynomial. Now, I think I forgot to check myself on number 4. So let's check myself on 4 and 6. Number 4, right there. Now, I had it written backwards, but that's okay. That's the commutative property. It doesn't make any difference. It's still right. Same thing for number 6. I wrote these two terms backwards, but that's okay. You still got the b out front. So our answer is right there as well. So there's regular trinomial factoring and then more complicated trinomial factoring that involves what we call grouping. Next, number 8. This is not a trinomial. There are not 3 terms. There is a way to factor it like a trinomial if you write it like this. But most people don't do it that way. I'm going to do it the most common way. This is referred to as a difference of squares. Difference means minus. Square means that we have a second power or we have a square number. 4 is the same thing as 2 squared. So you could really look at this like that. Now, as I said, difference of squares factoring uses a formula. I'm going to scroll back up and show you the formula. It looks like this. A squared minus b squared always factors the same way. It factors into a plus b, a minus b. So you don't have to think anything through. You don't have to make like a chart of numbers. You don't have to know any other fancy steps. You just put down your 2 sets of parentheses. Here, let me get rid of some of that mess there. You put n and n because m and m because m times m is m squared. And then you put down a plus sign and a minus sign. And then what's the square root of 4? What times what gives you 4? That's 2 and 2. So there's the answer, m plus 2, m minus 2. I'm going to go ahead and let's go ahead and check that. because this is what you should be doing when you're doing your homework as well. And there it is, m plus 2, m minus 2. Number 10, same thing. Difference minus squares, second power. 9 is a square number, right? 3 times 3. 25 is a square number, 5 times 5. So this is a difference of squares. Just write parentheses. What is the square root of 25n squared? Well, that's got to be 5n, 5n. What is the square root of 9? 3 and 3. Put in a plus sign and a minus sign, and that's it. It's a formula. It just always works. So number 10, right there. Now, if we look at number 12, this is not a difference. It's plus, and it's not a square. It's to the third power, which we call a cube. So this is referred to as a sum for plus, of cubes. Now, you might ask, how is 8 a cube? Well, 8 is 2 times 2 times 2, or 2 to the third power. So the first thing I'm going to do in this problem is rewrite it as x squared plus 2, x cubed, plus 2 cubed. And again, there's a formula for this. I'm going to write the formula up here on the note page, but it's a hard one to remember. This is a pretty easy one to remember. A, B, B, plus minus. So I don't really dwell on that one a whole lot. But this one is kind of complicated. So the difference, well, I guess I'm on a sum of cubes right now. Sum of cubes is a cubed plus b cubed. So that's like your original problem there. And here's the formula. It starts out a plus b, and it goes a squared minus ab plus b squared. So that's a little more complicated. I'm going to rewrite it down here so I don't have to keep scrolling up and down. A cubed plus b cubed equals a plus b times a squared minus ab plus b squared. So in this particular problem, the a is the x and b is the 2. B is not 2 cubed, a is not x cubed. A is just the x, b is just the 2. So what I need to do is I need to recreate this formula up here. Plus sign, a minus sign, a plus sign, okay? Everywhere you see an a, I'm going to write x. X, x, x. Now, this one has a square on it, so I need to put a square on it. Everywhere, let me change colors a little bit. Everywhere you see a b, I'm going to write a 2. So 2, I'm going to put a 2 there. Now you know that a next to b means times. So if I put x next to 2, I'm going to put the little dot there to represent times. And then for that last b, I'm going to put a 2, but it is squared, so I have to put squared. Now this is not the final answer. You can straighten it up a little bit, change it to x plus 2, x squared minus, x times 2 is more normally written as 2x, not x2. And we write it this way, we don't need a dot. And then secondly, 2 squared is 4, that's common knowledge, so instead of leaving that as a 2 squared, you rewrite it as a 4, and that's the answer. So I'm going to scroll down and check number 12, and there it is. Look, that was complicated. If you didn't quite follow it, number 14 is another example of the same thing. It's sum because there's plus. The third power tips me off that it's going to be a cube. And I just happen to know, a lot of multiplication facts. 5 times 5 times 5 is 125. So I can write this as 5 cubed x cubed. And then 6 times 6 times 6 is 216. I can write that as 6 cubed. If you don't just have that knowledge right off the tip of your brain, you can grab a calculator and just start multiplying a bunch of junk together to see if you can sort of recreate the numbers you see in the problem. Okay, so my formula. It's up here. Do I want to scroll up and down? Not really. Let's rewrite the formula. A cubed plus b cubed equals a plus b, a squared minus ab plus b squared. So we need to cram this information into this side of the formula? Well, in this case, A is going to be the 5 and the x together. So A is going to be 5x, B is going to be 6. So when I go to try to fill in this formula, I can go ahead and put plus sign, minus sign, plus sign. Everywhere there's an A, here, 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 here. Oh, sorry, not on this side. That doesn't really matter. So here, here, and here. Everywhere there's an A, I'm going to write 5x. So what do I put here? 5x. Over here, I do put 5x, but the formula does have a square on it, so I need to stick a square on both of those. And then right here, 5x also. I like the way that color coding worked out. I'm going to do it again. According to the formula, I put a b here, here, and here. Here, here, and here. B is 6. So put a 6, put a times 6, put a 6, and that last one is squared, so I also have to square that. Finally, I can kind of clean this up or straighten it out or whatever. Make it 5x plus 6. What is 5 squared? 5 times 5, 25. 25x squared. Minus, what is 5 times 6? That'd be 30x. And then at the end, what is 6 squared? 6 times 6 is 36. This is the factored version of that. Let's scroll down and check number 14. Try to keep that in your short-term memory. We'll look at 14. There it is. Right there, and I think everything matches. Now, that was only 2 examples. If you need more, if you were to go to YouTube and type in sum of cubes factoring, something like that, you will find countless videos that you can watch. Maybe someone will do a better job than me, so don't be afraid to go look back at that and, in YouTube and find some extra help. What we're coming up with next is difference. Remember, minus is difference. This is a third power. 64 is a cube. It does happen to be 4 times 4 times 4. So I could look at this as x cubed minus 4 cubed. Now that I know it's a difference of cubes, I'm going to use the difference of cubes formula, which I have not written down yet. I'll put it right here. Let's see, I circled that one. Let's circle this one, and I'll circle this one when I'm done. So a cubed minus b cubed, difference of cubes. Parentheses, a minus b is how it starts, and then it goes a squared plus ab plus b squared. That's the formula for a difference of cubes, and all we really look at is the right-hand side. The left-hand side is like the problem that's given. Now you'll notice there is some similarity between these two. Really, they're identical, except a plus and a minus sign are switched around. So the process I'm going to do on the rest of the examples will be very, very similar to what I did on 12 and 14. So again, if you had trouble following along, this is another chance to maybe try and have it work out for you. Let me go ahead and write the formula here. So a cubed minus b cubed, that represents the problem that's given. And then the formula is a minus b times a squared plus ab plus b squared. So in this problem, my a is the letter x. Everywhere there's an a, I'm going to write an x. Let me go ahead and do that. So one set of parentheses, bigger set of parentheses, a minus sign, a plus, a plus. So everywhere there's an a, here, here, and here, I'm going to write x. X, x, now this one gets squared, and x. Let me change colors. In this problem, b is going to be the number 4. So everywhere in the formula there's a b, here, here, and here. I'm going to write down the number 4 in my answer. 4 times 4, 4 squared. Now this is not your final answer. You can straighten it up a little bit. Right here, x times 4 you would just write as 4x, and then 4 squared is 16. Let me go down and check number 16 and make sure that's right. And there it is. All right, we got one more to do and we're done. Although, this is a video format, so if you wanted to just stop and start your homework because you get it, that's fine. You don't have to watch to the very end. However, I do want to remind you that you are expected to show your work as much as possible. That does not mean you have to do every problem exactly the way I do it. You don't have to write everything out the way I write it out. If you have another way of doing it, that's fine. I can do problem number 2 without showing any work, and I expect that most of you can too. So if you don't show your work on a problem like number 2, I get it. Same thing for number 8. Really, if you know the formula, there's no work to show. And but like these difference of cubes, sum of cubes, there's definitely stuff you can write down. Basically, you want to be able to prove to me that you didn't just copy these answers on your homework and submit it. So before I finish number 18, just want to reiterate, you do need to show your work. I understand on this assignment that there's no work to show on several of the problems, and I'm okay with that, but do something on most of the work or most of the problems to prove you didn't just copy them. All right, let's finish number 18. So this is another difference of cubes. Difference because of the minus sign, cube because of third power. Remember, 125 is 5 to the third power. And then 8 is 2 times 2 times 2. That's 2 to the third power. So I'm going to rewrite this as 5 cubed u cubed minus 2 cubed. I'll rewrite the formula up here. A cubed minus b cubed, a minus b, a squared plus ab plus b squared. So in this problem, my a is 5u, and my b is 2. Everywhere I see an a, here, 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 I'm going to write 5u. Although, give me a second to write in my plus and minus sign. Okay, so in those yellow spaces, I'm going to put 5u. 5u, 5u, 5u. But this first one is squared, so that means I got to square both of those, the 5 and the u. And it looks like I didn't give myself much room, so I'm going to slide that over. All right, change colors. B goes here, here, and here. There, there, and there. Everywhere there's a B, I'm going to write the number 2. So 2 times 2, 2, and again, this one is squared. That's pretty much the answer. You just straighten things up a little bit. So 5 squared u squared, I can make that 25u, plus 5u times 2, that's plus 10u, plus 2 squared, everyone knows 2 squared is 4. That should be the answer right there, and it is. Okay, if you're still with me, I do want to point out that I tried to make this fairly simple. So your number 1 is going to work out a lot like my number 2. Your number 3 is going to work out a lot like my number 4. 5 is like 6, 7 is like 8, etc., etc. So the examples I did should line up with the work you need to do this time to try to make things a little simpler as you're working through these on your own. Of course, if you do have questions, you can email me or drop a question in the comment section, not of this video, but at the comments of Google Classroom, and let me know. I'll try to answer them as soon as I possibly can. And then